recording on Zoom? Okay, we're recording on Zoom. I'm going to see if I
Got
get
it.
the live stream going. Which one? Here we go. Start stream. Yes. Okay. Go live. Hold on. Boom. Okay, we are live, sir. We are live here today with Salvatore Pais, one of my favorite people on the planet right now. He is doing my first ever interview. This is going to be Hard Truths with Salvatore Pais and Ashton Forbes. So right off the bat, sir, go ahead and introduce yourself.
Never ever call me sir. Number one, call me brother.
Got it, brother.
That really goes to the soul with me. So, Ashton, thank you very much. This is an honor to be your first interview. So
Yeah.
I'm pretty sure there will be a lot more after this one. Trust me on that.
Oh, I love
now,
it.
And I hope to be in further interviews as well. That'd be great. Now,
Yeah.
All right, let me give a disclaimer right off the bat. I'm required to do this. So I come on this podcast as a private citizen, and the let's say the statements, speculations, opinions that I make are in no way implicating the United States Navy nor the United States Space Force. They are my own, and as such, I shall present them. Now, can I give 5 minutes sort of origins? And okay.
The floor is yours, sir. Sal, the floor is yours.
Thank you, sir. I was born in Romania. I'm very proud of my Romanian heritage. You can call me American apple pie made in Romania. I just love hearing that. I heard it once before, and I like that. So I will say something in Romanian so people are convinced that I'm from that. Sunt mândru că sunt român, trăiască poporul român, trăiască România, nimic fără Dumnezeu. Basically, it says, I'm very proud to be Romanian. Hooray for the Romanian people, hooray for Romania, and nothing without God. And as far as why I'm here, recently, a friend of mine told me that they have changed right after the Tim Ventura interview, where I gave an interesting rendition of the Pais effect called Pais effect Resurgence. By the way, I practically implore your audience and everyone on the live stream to Google the Pais effect Resurgence. Those three words, Pais effect Resurgence, it goes directly to a Tim Ventura page. We will tell one day whether it's taken down or not.
Yeah.
It's, another little point in the spectrum, let's call it that. Yeah, so basically in Wikipedia on October 18th, I believe, of this year, they changed right after the interview almost. They changed to say that my work now represents a scam, a pseudoscience, disinformation. When you go into Bing now, the AI agent never before has it done this. It calls my work crack pottery, and it's almost as if my work is starting to have a concerted effort to be undermined, shadow banned, and you have to question why. Especially after the Tim Ventura interview, you have to see that to see where I'm coming from. Now, it is very important to also understand that I challenge the mainstream physics community to send their best. We're talking about people like Carver Mead. We're talking about people like Seth Lloyd, Max Tegmark, David Gross, Brian Keating, Stefan Alexander.
Yeah.
Others, Frank Wilczek, any Nobel Prize winner they have out there. I wish to have a committee whereupon I'm given 1 hour, I'll go to the blackboard and prove to them that the Pais effect and the superforce concepts are correct. I'll show them exactly how they were derived. They're extremely simple and minimalistic math. I believe in Occam's razor. I do not believe that mathematical acrobatics should pass for great physics. As a matter of fact, I believe the simpler the mathematics, the more important the physics, especially if you have a good understanding of what the problem is.
Yeah.
Many times, great physics is found by accident. is not actually looked for. And one other thing that I wish to mention also is that this is not new physics. This is a new perspective on old physics. And this is what makes it incredibly interesting, because there's so many things out there that have not been tried yet. It is as if classical electromagnetism theory has been put aside the moment quantum theory came in. A lot of things that were introduced by Oliver Heaviside into the equation of James Clerk Maxwell were sidelined, and things that should have been looked at weren't. Anyway, I will not. There's one more thing that I need to say, because we have to be careful exactly how I answer certain questions on the Pais effect.
Sure.
Because unfortunately, as almost every other piece of physics out there, the Pais effect can be weaponized. Absolutely. And it can create a super weapon of all weapons, a weapons of such incredible power as to render the Teller-Ulam device a pop gun in comparison. And this is not hubris. This is mathematics and physics. Now, it is also important to realize that a weapon of this nature, any army, and I mean any army that would field a weapon of this nature first, would become invincible, number one. Number two, and this is incredibly hard, it's very, very important to understand what this super weapon would represent as a new epoch in deterrence. No sane nation is suicidal, and any insane nation should not exist. Hence, let's leave the super weapon in the realm of physics, but let the audience know, let your live stream know that certain things, numbers, frequency ranges, spectrums, I cannot discuss.
That's fine.
This is something that can be quite detrimental to national security if taken in the, how should I say, from the incorrect perspective. So I will not even touch on that. If I hope I have you understanding that if I disagree with a question, I will try to be as polite as possible, but I will say, in the interest of national security, I cannot answer that question.
Yeah, sir, you already went through like 4 of my questions right there from your interview, from your intro right there. And I just want to agree with you on that front. You know, I've heard you say multiple times that you are not a spy and you are not a patriot. I am also not a spy, and I am a patriot as well. And to that sense, the thing I would bring up is, this is actually one of the optional things I was going to bring up at the end, but you just kind of addressed it, is that my opinion is that most likely our foreign adversaries have already potentially figured out this type of technology, if what you're going to be telling to us is true. And what that means from a humanities perspective is we need to be very responsible with this technology, because I agree with you. I talked about it last night on my space, that
mutual assured destruction.
Agreed.
But it's a whole different epoch of deterrence that we are.
It's not just nuclear weapons anymore. Now we're talking about something that's millions of times more dangerous.
Something that can modify space-time. Exactly. And as a matter of fact, the Schwinger limit, breaking the Schwinger limit, points to that fact. This is physics. This is not crack pottery. This is not
fiction.
Physics.
It's just
no,
science.
Absolutely not. Sometimes I wish it was.
Yeah, me too, sir.
It is not science fiction. This is science fact.
And I'm like you. If I accidentally call you sir, it's just a matter of respect. I do that a lot for people that I respect, and you're one of the people that I really respect.
I have the same thing.
Don't take personal offense if I do it.
By it. My own boss is like, stop calling me sir. he's a great dude. So
yeah.
Anyway.
So you ready to dig into this thing? Because I think that you touched on part of what I want to begin with, which is you've mentioned in your previous podcast, and I don't want to rehash all the stuff that you've talked about before, especially with Kurt, who I thought you had a great interview with. I listened to the whole thing, and he's a very smart guy, especially when he was talking about quantum gravity. I just thought, wow, this guy is super intelligent.
Oh, Kurt Jaimongo is truly a theoretical thing. If he was representative of the mainstream physics community and he had a say, I'm 100% that at least he would give me a hearing.
Yep.
At least.
And I think that our plan here, what I want to do is hopefully vindicate you in their eyes as well and get that hearing that you want. Because I think that what we're going to be talking about today, the physics that we're going to be going over, is practical. It's stuff that can really exist, and we need to make sure that it gets the proper respect. And that kind of goes into my first question and point, is that you've mentioned that your papers were submitted to, I believe, Cornell, and they wouldn't publish them without a sponsor, right? Why do you think that is? What do you think your view is there?
Cornell University Archive is, in my opinion, the best preprint service of all time. As a matter of fact, once you publish an archive, most likely your paper will be published in a highly impacted journal. If not a high impact, at least a moderate impact journal. So in other words, 100% your paper will be published. So I have great respect for archive. The fact that they need sponsors, maybe it's quite possible that a lot of individuals put certain physics in there that is, look, Joe the plumber can write a physics paper if he understands the precepts, the foundational, the fundamentals of physics. Once you understand them, you can write a physics paper, and even Joe the plumber can publish on archive if he has a sponsor, unfortunately.
Yeah.
But the whole idea being is we're not living in the time of Einstein, where basically a Swiss patent clerk can get 5 papers published. This is the Anno Mirabilis, the year of the greatest 5 papers, in my opinion, that opened physics to a whole different dimension of reality, of possibility, conditional possibility. There's no such thing as impossibility. There are only conditional possibilities. But to go back to the idea of why I think archive is blocking and needs a sponsor is sometimes you cannot just go on archive and say, look, Einstein was wrong, and here's the, please, there have been so many proofs as to the fact that the gravitational field equations of Einstein must be at least partially correct, because there's so much experimental evidence for it. So if you have a theoretical argument against Einstein, then you must argue from a very strong mathematical and physical background and also present experimental proof. And some of these papers, unfortunately, do not. Now, I understand where they're coming from. However, in my opinion, we do not live in the time of Planck and Einstein and Heisenberg and the great ones. Even Feynman. I mean, Feynman is, we're talking about 1950s. Still, we don't live in those.
So I think
it's extremely hard to publish. And sometimes people that should not even get there because they know the editor or the chief editor, please, nepotism in physics, unpermissible. And
that's what I would argue as well, just to kind of, not to cut you off, but I think that I agree with you there. And what I would argue is that academia has kind of forgotten what science is, right? Science is a scientific method. It's the study of observable reality, of being able to experiment and be able to prove concepts, and I think that now what you just pointed out is that it's been inundated with credentialism, right? And saying, who do you know and what do you know? And so, one kind of point that I would say, kind of closing that bit off, because I think that you have been done a disservice, is that sometimes seeing is believing. Imagine if we had video proof or experimental proof out there that could prove your concepts, right? Maybe that would give another level of credibility to the things that you're saying.
Absolutely, sir. Absolutely. Experiment trumps theory every time. Totally Again, agree. Experiment trumps theory every time.
Absolutely.
And it's an interesting verb, and a lot of people get a little itchy when they hear that word. But still, experiment trumps theory every time. Now, can I just give a quick rendition of the Pais effect resurgence?
Oh,
because it's important for people to before in my papers, actually in my patents, there was one paper that I was able to publish in a high impact journal, IEEE, Transactions on Plasma Science. It's on the plasma compression fusion device. And the chief editor had two different, I went through 2 different review boards. I mean, it took a long time, as you can see. If you look it took a long time for me to publish this paper. I went back and forth, argue this, but at least they were open-minded enough to realize it was something new, something worthy of being seen. Again, this is all I ask for, is a chance to express myself, to express this physics that I think can have some meaning to the progress of civilization. I want nothing more. I don't want royalties. I don't want money for that. I don't want anything except the progress of civilization. We need unification of civilization in order that we do not perish from this earth. I'm afraid of the future, sir. It looked extremely bleak at this point in time. And we either come together and as one unification, one unified civilization, or we shall perish.
That's what I've said many times as well, actually. And I think that what you said about science is very accurate too. And that the way I've seen science too is that it can be encrusted, very molded, and that it takes somebody to push it forward, break through the barrier, right? And with your science, that's what I see, is that I see that people don't want to believe in it because they haven't been told that it's possible. And if they were to just look at your math, look at your models, I think that they would realize that there's something there that's actually substantial, and then it can push us forward. The thing you said about unification, I say that almost every single time, is that we live in such a divided world right now, where if we get that unification, this science could potentially be that thing that unifies us towards common purpose, right?
The physics of the superforce, in my opinion, can bring about unification of mind and soul.
Yeah.
The two should not be driven apart. They're one and the same, one manifestation of the other. All is one, one is all. This is the true basis of Hermeticism, and this is the true basis of all future of civilization. If we have a chance to survive, this is it. Unification of civilization. It has to be a common goal, a common objective. And why not? I remember at one point, Eric Weinstein, as a matter of fact, mentioned one time, travel, maybe this should be our final objective, to leave this earth, break the shackles of earth, break the bounds of earth, and become an interstellar civilization. That maybe, just maybe, will give us a chance for survival. The road that we are currently on is total abysmal and perdition.
Couldn't agree more. So let's attack your
effect quickly.
Oh, actually, I was going to go to that in just a second. I think that's the next question, if you don't mind, because what I want to do is I want to debunk this. There's a debunk of you. So the biggest thing I think your detractors mention when we talk about your patents is they claim that you can patent anything. Now, what I read from watching your last interview is that only 3 of your 5 patents were even approved, which to me would indicate that it's not true. So I would like to get your opinion on that, sir.
There's very simple way to debunk I don't even know what the correct terminology is anymore. For example, I don't use UAP, UFOs. You shouldn't erase 70 years of history just because you think that new terminology would somehow eliminate the derision. The derision is far more basic than that. History is important, sir. Never forget history. Okay, but anyway, the way to argue that is look at the office actions of a great primary examiner called Philip Bonzel of USPTO. Oh my goodness, him and I went back and forth between him, Mark Glut, who is the United States NAVAIR patent lawyer and also a good friend of mine, an amazing patent lawyer. Trust me, anybody that can write those, and also the office actions, you should see what Mark did. You should see what Mark Glut did with the office actions in response to Philip Bonzel. Philip Bonzel, I mean, he really bit into the physics. He said, you cannot tell me that it's possible to create electric fields on the order of 10 to the 18 volts per meter and magnetic induction, otherwise known as B fields, magnetic flux density on the order of 10 to the 9 Teslas. And it's an easy way to remember that. It's E equals CB, C being the speed of light in free space. But anyway, so that's how I remember the numbers. Sometimes I forget them myself. But the whole idea is once you're able to create, it's not exactly that you create E and B of that. It's the energy density that you can create. from rendering the Pais effect. And the Pais effect, speaking to the Pais effect,
Yeah,
is it
let's go
okay
to
if
it.
I give
Yeah, I think that's a good segue. That was my next thing. So jump on in. What's your definition of the Pais effect for our viewers?
Okay, it can be thought of as controlled motion of electrically charged matter going from solid to plasma, undergoing rapid acceleration transients via accelerated vibration and or accelerated spin, leading into very high energy densities being formed. Because remember, the electromagnetic energy flux is really the speed of light c times the energy density, the epsilon sub naught, the epsilon, sorry, sometimes I drift into my English. So the epsilon 0 times the electric field square. So C times epsilon 0 times the electric field square, that is your S, the magnitude of your Poynting vector, let's call it. That's the electromagnetic flux. And that electromagnetic energy flux, if it's on the order of 10 to the 33 watts per meter square, which really corresponds to a energy density on the order of 10 to the 25 joules per meter cubed, then we can break the Schwinger limit. If we can achieve anything past that, those particular values, we can actually put it this way: vacuum decay, complete vacuum decay.
Interesting. So
the Schwinger limit is really the achievement that all of a sudden the very quantum fabric of space-time is unraveled. It breaks apart, it tears apart, and you can see it by the formation of particle-antiparticle pairs. This
I've
is
heard
the
you
way
talk about this quite a bit. Now, real quick on that, the vibration.
Okay,
keep going.
Let me give. I'm sorry,
you're fine.
Ashton, I promise this is the only time I'll interrupt because it's important to see
go for it.
That's why I call it the resurgence of the Pais effect.
Yeah.
Another way to see what the Pais effect is all about is to say it's really the generation of extremely high energy densities that are obtained by the accelerated vibration and or accelerated spin of a non-equilibrium plasma. That means the plasma that's out of equilibrium. You can think of that. They have a term for it called cold plasma. Cold, as in non-thermal plasma, and it really has to do with the electrons of this plasma that talks to the plasma density is very high. I cannot go into numbers, but anyway, okay. So what? Right. So these, but the number of these electrons do not observe something called a Maxwell-Boltzmann distribution. That's what a cold plasma is all about, an out of equilibrium or non-equilibrium plasma. Once you drive that far from equilibrium at a particular vibrational frequency, you can induce extremely high energy densities. If you do this locally, think of it, the thing popped into my mind sometimes, this is some crazy stuff, but anyway, think of it as a steak. You take the meat tenderizer, the big hammer, and you keep on pummeling at the same spot over and over. What do you see eventually? A hole. A hole. Ain't that interesting?
So is that the vibrational acceleration there that you're kind of describing?
What I'm describing is the unraveling, the ripping apart, the tearing apart locally of the space-time fabric at a quantum level, determined by this incredible amount of energy density that is put at that particular point. The more energy you put in a particular point, the more that in that locality, space-time will break apart, will tear apart. And it's possible that a hole will develop like a black hole almost, if we truly understand what a black hole is. But you see, just like Frank Wilczek, Frank Wilczek also believes in the materiality of the vacuum. In other words, we're dealing, I'm not quite sure if it's a crystal lattice. We're not talking about time crystals here, even though that's another thing that Professor Wilczek is greatly known for. But we're talking about almost like a the on a, at a quantum level, you can think of space-time as being a material. It could be a superfluid, but it also has almost a space-time geometric structure to it.
Yep.
And that's what my superforce speaks to.
What is your
It
thought
may
of this
not
idea?
be mine. It's
Yeah.
quite possible others have come up with these ideas before,
Yeah.
but the equation 1 in that Superforce paper, and please post the Superforce paper and also the AIAA paper and also the IEEE TPS paper to your live stream and send it to everyone you know. Those 3 papers best represent my work. I believe in the number 3, like a great man that once lived, and I shall not mention because I mentioned him before, and he, trust me, this Nikola Tesla will go down in history as one of the greatest we've ever had.
I agree with you, sir.
And the way he was treated, abysmal, absolutely abysmal. That dude, JP Morgan, watch out if you know what I mean. Anyway, yeah.
Yeah. So yeah, I think that interesting enough. So I think for people who are in the chat, you know what you just said about the papers, I've posted them on my Twitter before. I'll throw them in the description later on as well. But share those papers. Sal here is telling you guys that, you know, share them far and wide. Those are very important. Now, with respect to some of what you were just talking about around the Pais effect, you know, I think that what I saw in one of your past interviews too was that using vibrations as opposed to spin is potentially more beneficial. Could you explain that a little bit?
Yes, sir. You can, for example, we tried an experiment called the high energy electromagnetic field generator to see whether we can get the magnitudes of the pointing vector, namely the electromagnetic energy fluxes, very high up based on accelerated spin of an electrically charged object. Unfortunately, we could not get an electric charge more than 10 to the -8 coulombs. You put that in that sigma squared term, which is the surface charge density squared, and you'll see it's quite a deterrent. We're talking about 10 to the -16 going against you. And even though we try to make the test section very small, it's still. However, for anyone that's out there and wants to see further what the high energy electromagnetic field generator experiment brought, I encourage them put a FOIA in and actually get the unclassified report. There were 2 anomalies. There were 2 anomalies that were observed. As a matter of fact, some very highly placed people from the technical committee of the Senate Armed Services Committee came to NAVAIR PAX to interrogate, how should I say, the members of the Invention Evaluation Board on why they passed these 5 patent applications. Because a lot of people said that if anything, these should have been classified. So there was a whole team that was sent from the Senate Armed Services Committee to investigate. I'm pretty sure that that certain individuals, I shall not name names, but they must have said, oh, this was a scam. This was a total misappropriation of funds, even though we're talking about only, what, 0.5 million for like, I don't know, like 15 people over a period of 3 years? Please, I mean, do the math and you'll see what I'm talking about compared to some of the stuff that's going on. But anyway, I shall not make it too dark. No. Now, so the whole idea being is there's a report out there. It's unclassified, and it talks about so even with a charge like 10 to the -8 coulombs, instead of the 1 coulomb needed to get the kind of energy densities we were truly looking for, to observe certain phenomena that I cannot discuss. Those are anyway. Yeah. Even with that, 2 anomalies were reported, and actually in the report. So that's interesting.
Yeah.
I'm experimental observations. We're not talking about theory here. We're talking about experimental observations.
And that's my next question too, related to this accelerated vibration. Like, what's the delivery mechanism? Can a laser do that, or can you speak to that, or is that
Sure, sure.
more,
I shall speak with it, but only in the general.
yeah,
Just
sure.
to point that it is very interesting that the 2023 Physics Nobel Prize went for what? Electron dynamics induced by attosecond lasers.
Yeah,
10 to
interesting.
the minus 18 second lasers.
Very
We're not
interesting.
talking about femtosecond. We're talking about attosecond. There's a reason. So let me just leave it there.
Interesting. Yeah.
Okay.
And are you familiar with metamaterials, sir? Probably, right?
I have some familiarity with that, yes, sir.
So,
But
yeah.
I would rather not discuss that portion.
Okay.
It has
Sure.
something to do with certain things. So
Yeah, that's fine. So let's
sure.
go on to the next one then. In terms of your
Yeah.
patents, and this might be a question I don't know if you can answer or not, but do you think that these patents are operable today?
Yes,
Based
sir.
on what we know about technology?
See, a lot of people have questioned on that and said, how dare the USPTO publishers? They were not properly enabled because, you know, all the ingredients are there, but you have to know what you're doing, number one. Number two, it is important to understand the nature of the materials, the piezoelectrics, exactly how they operate. For example, what is the main difference between strontium titanate, barium titanate? What exactly is something called the Mossbauer effect? Anyway, I mentioned it actually in a publication of mine, one of the few papers I was able to actually publish in a journal, but only because it was in the beginning of the journal. And I think my opinion is that the chief editor needed papers more than anything. And he was taken aback by the what's the best, the ambition of the idea. Let's put it was actually the high energy electromagnetic field generator, that paper that I published. I think it was the International Journal of Space Science and Engineering. And trust me, I tried to publish the Superforce paper at the same journal, thinking, you know, I published the conditional possibility of spacecraft conditional possibility of spacecraft propulsion at superluminal speeds, and that high energy electromagnetic field generator in the same volume. I think it was volume 3 of I think it was issue. Anyway, it was they were both published in the same volume. One of them as a technical note, the other as a full-fledged paper, a technical paper. I tried to publish the Superforce paper in the same journal. They would not. It's as if my name is on some sort of a blacklist. You know, Salvatore. No. I'm talking about sending papers and having rejections within a matter of 12 to 15 hours. Wow.
That's interesting.
You know what I'm saying?
I don't know. Have you ever gotten the my results are changing quickly? If I Google you right now, is that going to happen? It's a bit of a badge of honor, you know.
Between you and I have some friends back in New York City that how should I say, they watch for my statistics. One of them said, dude, one time I Googled your name because he watched it. He actually has a statistical chart of it. He said that at one point in time, when you Google Salvatore Pais, you got over 300 million results, and all of a sudden it dropped to like 7 million, and then it went up. He had no idea what was going on. He said, "This is not possible. What are we talking about here? I mean, you have numbers higher than Andrew Tate." You know? but I hope I didn't get anybody canceled from even mentioning.
No, I don't think so. At least
it's
not in the sense that
he's
you argued
connected
it.
to Romania. So anyway.
So
right.
I think I wanted to jump into the Superforce in your equation number one, which you wanted to talk about, because I read through your paper. I looked through all the patents as well, tried to do my best as a layman to understand them. And when I look at your Superforce, you know, especially with equation number one, it basically says that if you look carefully at the mathematical structure of the Planck force, you can realize that this is the superforce. It does not contain the H bar. I've heard you say this, namely the modified reduced Planck constant. Therefore, it can relate to quantum phenomena exhibiting macroscopic classical behavior, namely a macroscopic quantum phenomenon. Now, when I look at that, I think, are we talking about a unification of quanta and macro? And is that how you would argue your equations here?
Absolutely, sir. Equation 1 speaks to exactly what you're talking about. And as a matter of fact, page 2 of the paper, it's just a 3-page paper. I mean, anybody, for goodness sake, oh, maybe that's why I got a 15-hour rejection, because it was extremely fast. But, just that equation 1 is so powerful, because I will tell you what it says. It actually says it's the superforce that is the energy gradient at both the Planck scale and the energy gradient at the horizon scale, which is when talk about observable universe. How is that possible that the superforce can be the energy gradient at the very lowest of scales, signifying the lowest of our realms, the quantum realm, and also the highest that we understand, the observable universe? Not only that, I believe because of the way it's fashioned. For example, if one day we were to find out that our universe doesn't have an observable radius, say, of like on the order of 10 to the 27, 10 to the 27 meters. It has something on the order of 10 to the 80 meters or something of that nature. That equation would give you how much mass is in that structure, which would think what that means. It means really we're living in some sort of a matrix, like a space-time geometric structure that can be altered.
A construct, right? A construct.
A construct of some sorts, which is, I'm not going to talk to the simulation hypothesis because I think this is very real. I believe when I pinch myself, it really hurts. So, Einstein said something far, far, far more subtle and far more philosophical in nature. Namely, he believes the moon is still there, even though he's not looking. I absolutely.
That's a good argument. Yeah. And I think that we can, the spiritual stuff we can dig into potentially in the follow-up interview, because I think that we probably are on the same wavelength there in terms of our beliefs on that. And the only thing I would say is that from my own personal perspective, the more I dig into the science and dig around the science, especially around this, the more spiritual I actually become. I thought it would be the opposite, but it turns out that no, I think that I have more of a spiritual understanding the more I dig into science, which is very interesting.
And I want equation 1 from now on to be addressed as the superforce equation.
Got it.
If Michio Kaku can say that he has the God equation, then I think my hubris level is far lower by saying it's mine is the superforce equation. Okay.
It was the way you explained it. I think I've heard you say before as well, is the superforce is acting on space-time geometric structure at all points in space and time as well.
Absolutely.
Is that an equivalent definition?
Which means what? It also speaks to quantum entanglement. That means every point in space and time is connected because of the existence of this superforce. Yes, it exists at 10 to the minus 35 meters, which is the Planck length, but still, one more thing the superforce equation speaks to, which is when I realized that, I said, whoa, my goodness. If you put in that equation, so the superforce, the equation for it is c to the power of 4 divided by big G. So it basically says speed of light to the 4th power divided by big G. And if you put in, if you realize there's such a thing, for example, if it talks to an energy gradient at every scale, because that's what equation 1 really says. If it goes from the very smallest to the very highest, maybe it goes for everything in between. So I tried the mass of the proton. Guess what the superforce says? I put in the mass. So in the superforce being mc squared divided by that characteristic length, I put in the mass of the proton, which is like 10 to the minus 27 kilograms. And guess what I get? I get a characteristic length on the order of what? The Schwarzschild radius for proton. So the proton is treated by the superforce as a black hole. No wonder the proton takes so long to decay, if ever.
Got it.
That is an amazing equation. The superforce equation will one day be known by physics everywhere, I hope. You
I
know,
hope so too.
and I do not mind if they rederive it, they call it their own, but at least, you know, somewhere in a footnote, they say, you know, some crackpot called Pais thought of this too. You know,
We're not going to
it'd
call
be
you
nice.
that. I
I
want to be
get a
respectful about that. I
sensation
know that you're sensitive as well
and
about
anomaly.
what people
Yeah.
call you. And I think that that's part of the vindication that I want to go through with you as well, is that
I tell you, sir, I've been, I mean, well, we talk about blood, tears, sweat, and misery of the mind and the soul over this. Because the moment they called my work, and I understand, maybe I understand, I'm not quite sure exactly why the Drive War Zone called my papers the UFO patents, the UFO Navy patents. The moment, again, it became a symbol of ridicule, and mainstream physicists would not even look at that because, again, symbol of derision. And I understand why they changed the terminology to UAP, but you shouldn't, because we're talking about the history of so many people that were involved in the subject matter. And for them and them alone, we should leave that term as is. My opinion, the U in UFO should be unacknowledged.
I agree with you.
But
I agree with
anyway,
you on the UFO thing as well. And I also don't want to link your work to UFO because it's really just science. It's not necessarily related to UFOs, although there's obviously a connection there because from what people see, it can describe that as well. So, you know, that's why when we look at the description of my discussion with you, it doesn't mention that at all, because what we're digging into here is the science, right? We're digging into quanta and macro unification. We're going to dig into superconductivity here in a minute as well. And that's the stuff that I want to learn about, the stuff that's not fiction, that's just science. So one quick question,
one more thing about the second,
go for it.
Sorry, about, and I promise you not to interrupt again.
Oh, you're fine.
Bad.
It's your show here, sir.
No.
You're the star.
Me, this is your first interview, so I should be a little more polite. But this is my chance to say certain things. And who knows? Maybe I get a word from command, shut the, and I can. And this may be my last interview. Who knows? Who knows? Anything can happen. The truth is. But as Andrew Tate once said, I will never suicide myself. But anyway, okay. Now, the idea being. On the second page of that paper, of the Superforce paper, take a good look at the way that I prove that this is the force of unification. There's a remarkable formalism, very simple, that the strong nuclear force divided by the electromagnetic force is 1 divided by the fine structure constant. It's usually on the order of 1 divided by 137. It's like 0.07. But anyway, and it's very interesting that when you actually take the decimal of that 1 divided by 137 and do it in a calculator, and you see what I'm talking about, it's as if the numbers become a wave. It's as if the numbers, it's a vibration or so. It's very strange. Just look at the way the numbers change and how it's, trust me,
interesting to
do
me.
1 divided by 137, and you'll see what I'm talking about. Now, what's truly okay, what was so using that idea, I was able to show very simply that the strong nuclear force equals the gravitational force at the Planck scale equals the superforce. So that the strongest of the forces that we know of, the strong nuclear force, which operates on the order of 10 to the minus 15 meters, so 1 femtometer, and the gravitational force, which is the highest that we know of, hence the general relativity, the Einstein field equations, and so forth. So those two scales are at the Planck scale. Those two forces are equal and equal to the superforce. Hence, the superforce is a force of unification.
That makes a lot of sense.
And you can actually find on that same page, very simple with some rudimentary math, something that I called in another paper conditional replacement technique. And one can Google it and see what I'm talking about. The CRT. Some people called it at one point cathode ray tube. I just don't. Anyway, the conditional replacement technique, if taken simple in that linear equation, you can actually show that in both the Dirac and the Schrodinger equations, the superforce exists because it's an energy gradient at the Planck scale.
So do you believe then that
it's so simple This is why I love it, because I like simple mathematics that points to great physics.
Yeah.
That idea of coupling the two amazes. I understand that a lot of people are fascinated by ER equal EPR and ADS equals CFT and so forth. And we can discuss this at one point in time. But I'm sorry, Juan Maldacena, we live in a de Sitter vacuum, as Eric Belinda once pointed out. I'm pretty sure Juan will be very mad at me at this point in time. But anyway, Lenny Susskind too, but I have great respect. By the way, Lenny Susskind started out his thing as a plumber in Brooklyn. Ain't that some? Speaking of Joe the plumber,
Yeah,
he became
doesn't matter where
one
you
of the
start, right?
best theoretical physicists. Oh, I would love to have him on the committee as well. He's one of these visual mathematicians. He believes in geometries. That's a very interesting mind. The way his mind works, Lenny's, and he's like at a certain age, and yet I couldn't tell. I mean, the man is a giant. It's a cerebral giant, you know. So age, advanced age doesn't mean a thing.
No,
Just like pedigree doesn't mean a thing. Why shouldn't the Joe the plumber be able to even publish in archive? Because
totally
most likely, if you can publish in archive, maybe your paper will be seen in Science, Nature, physical review letters. It'd be nice. But anyway, that's a dream. All right.
So I just, for the viewers, you know, when we talk about unifying quanta and macro, I think I saw a question that was kind of helps for them to understand. Do you believe that faster than light communication is possible based on your equations that we talked about the Superforce?
We have to be careful to understand the nature of the medium.
Okay.
Within the same medium, so in other words, I believe a medium speaks to a given light speed, most likely having to do the index of refraction of that particular medium, and also coupled with the speed of light in free space. There's a very simple formula that you can see. It's a ratio. But anyway, so in other words, if we're able to modify the medium, it is quite possible that so-called faster than the speed of light is feasible. But within that given medium, no, Einstein was correct. It is a quote unquote physical barrier, but only presented by the nature of the medium. That medium can be tenderized. You can tenderize it to the point a hole is formed if you put enough energy density at that particular point in space and time.
Cool. So I appreciate that answer. I think that helps out with the viewers quite a bit. And I think the next thing we want to jump into is superconductivity. So can you define superconductivity for the audience? And then in addition to that, you talk about high energy densities. Can room temperature superconductors achieve those densities, and how so?
Okay. That second one, I would rather not discuss for reasons that I've said before.
Got it.
The first one, it's in the theoretical realm. Oh, speaking of which, I believe Leon Cooper is still alive, and Stefan Alexander knows him. I would love him on that committee too.
Okay.
And we're talking about the BCS theory of superconductivity.
Yeah.
We're talking about one of the, I should not use the term gods to describe men, especially since hubris may be greatly involved. So, but he is one of the giants of superconductivity, and I believe he's still alive. And also Brian Josephson, SQUID, superconducting quantum interference devices. Oh my goodness, the stuff that he can do with that. But anyway,
I hope some of these people are watching so that they, you know, you're name dropping a lot of people who are really smart. So
yeah. Both Brian Josephson and Leon Cooper are more than welcome on that committee. I would love to hear. Oh my goodness, they're such giants. But Carver Mead has to be there. I mean, this is a man. This is the father of true in my opinion, of semiconductor technology. But not only that, he has such ideas. For example, even in gravitation. But because he has the pedigree as an electrical engineer, even as a professor at Caltech, that man is not being heard properly by the community that supposedly he's not part of. Science should not have limits.
Agreed, sir. So what's your definition of superconductivity for the audience?
Superconductivity, well, I would put an electrically charged superfluid could be a superconductor. So the idea being that it's possible that we can actually slow photons in a superconductor.
Interesting.
And
I've heard that.
Interesting, isn't it? Yeah.
Very interesting.
It talks to the ability of medium. Now, a superconductor itself is really basically zero resistance as the electron flow goes through a certain medium, say a wire. Let's call it a wire, for lack of a better term, even though the way electricity actually moves along the wire rather than through it is very questionable. But anyway, I should not go there because I'm already called a crackpot. I don't need. So even though there was a very interesting podcast on Veritasium as to that illusion that okay, I'm diverging. I'm taking so many times.
No problem.
So the whole okay, and there's one more thing that defines a superconductor. That's the Meissner's effect. That's the ability of the superconductor to actually, I believe it actually forms a magnetic field of itself, of its own, some sort of eddy currents that actually form on the superconductor, and something called the London penetration depth. See, a magnetic field will actually penetrate the superconductor.
Interesting.
Unlike
because I thought it warped around it.
See, that's the beauty of it. It actually goes to the London penetration depth, but what it does, it forms eddy currents which talk to a magnetic field opposite that repels the magnetic field that's put upon the superconductor. So yeah, but there's a London penetration depth, and you can. I remember that I wrote a paper. I think the room temperature the AIAA SciTech speaks. It was a presentation that was based on a paper that I wrote, that I presented at AIAA SciTech 2019. And please make sure you post that, because slides 4 to slide 9 is extremely important. I even, in one slide, actually solved the vacuum catastrophe. You know, the whole idea, you know.
I'm looking at it right now.
That we get 120 orders of magnitude difference between the quantum realm, and how is that possible? Well, it speaks to the idea that maybe we're not dealing with Planck lamps here. We're dealing with some space cells of a different dimension and terahertz frequencies. Ain't that some? But anyway, yeah, that's as far as I go. I should not say more than that.
We're broaching a little on the edge here, huh? So, well, I got more then. They might broach even further.
Drops all of a sudden. I tell you, call me.
Okay. So the next one, though, is related. I don't know if you can dig into this, because I heard on the Theory of Everything podcast, too, you were mentioning that Bose-Einstein condensates can allow for room temperature superconductive effects. Is that something you can elaborate on? Or is that also kind of pushing it too far?
That's more okay. To understand how the room temperature superconductor that I'm talking about, which is an active room. See, I believe that maybe one way to solve superconductivity at room temperature is not necessarily by material properties, to actually find, for example, LK99 and so forth. You know, the whole idea of finding a specific material, copper, barium, strontium type. No, maybe it has to do with the way that you can influence something that is already a superconductor at very low temperature, but make it a superconductor at much higher temperature, so raising the critical temperature. And actually, there's a great paper out there still on archive, and one can Google it. Hopefully it's still on. Hopefully they haven't taken it down. There's a lot of concerted effort to make my work look like pseudoscience. So someone Google it fast before it goes. It's written by Dr. Victor Lacno, Viktor Lacno, or Victor with a C. I'm not sure.
I heard you reference him before.
But his last name is Lakhno, Lacno. And he's from the Russian Academy, a form of the Russian Academy of Sciences. He wrote a paper called something, The Road or the Way to High and Room Temperature Superconductivity, something of that nature. It used to be on archive, but in reference 10, he actually speaks to the idea that the way that I do it, the way he believes that that my idea on the room temperature superconductor is possible, is that what I'm really doing is forming a Bose-Einstein condensate and then actually moving the condensate because of a certain vibration within that field. Because and you can actually read his paper and see the last paragraph, and he references me. It's the only I believe the only paper out there, in the academic, quote unquote, academic community that actually references that particular idea. And I think he's got a point. Somebody read that paper carefully. It's the last page, and he references my patent in reference 10, I believe.
Oh.
Still remember that. Yeah, he actually wrote a book recently on high temperature superconductivity as well. But anyway, I digress. Sorry.
Yeah, so no, you're fine, because that's actually, I think you just said the last thing. The next thing I was going to say, which is I heard you say that in a previous interview that extremely low temperatures can create the Bose-Einstein condensate, which can allow things to move as one, the electrons potentially, if I'm saying that correctly.
Yes, sir.
And that they might
What we
even,
talk about
yeah, go ahead.
is macroscopic quantum coherence. The idea that it's possible under certain conditions. For example, what's a superconductor? A superconductor is really, in the words of Phil Anderson, the idea of emergence. Now, Phil Anderson, Nobel Prize winner, great mind. God, I believe he's deceased, but he at one point he was talking. I forget exactly how he tackled that problem. Anyway, I digress.
Oh, that's fine.
Look into the work of Phil Anderson and his
Okay.
idea of emergence and how he links it to something called macroscopic quantum coherence. How a physical object of classical size can behave as a quantum entity under certain conditions.
What's the difference
That's
between
what
that and macroscopic quantum decoherence as opposed to
Now,
coherence?
decoherence, exactly. Decoherence, that is the, some people think, for example, the gravitational field could be a decoherence method by which something that should resist or should have a quantum mechanical, actually it was Roger Penrose that mentioned that. But anyway, the whole idea is decoherence, it's one, as a matter of fact, look into slides 4 to 9. It's in there.
Okay.
Look into slides 4 to 9 in my AIAA SciTech 2019 presentation. It's in there.
I'm looking
It
at it right
describes
now.
macroscopic quantum coherence to a T. And as
Got
a
it.
matter of fact, if you have it up, read what I write in that particular slide. Like, read the whole thing. I still remember being in that room. I actually got a standing ovation for that slide. They were
Yeah.
absolutely, I mean, people was weird. I felt so good being able to talk to my peers and getting some feedback that was not so negative in nature.
So I'll just read it
That
out
was a
right now
great
if you
room.
want. There's
And
a couple of
actually,
bits.
do you know who presented before me in that same room? Robert Zubrin.
Nice.
We actually met. The great guy too. But okay, you go ahead and read that, please.
Yeah, because
Okay?
I think I quoted this when I was posting these slides on Twitter, because there were so many slides I had to break them up into fours, and part of it was saying that this is a vacuum that's undergone macroscopic quantum coherence locally around the craft. As a result, the craft experiences suction into the conditioned vacuum. Another part of it says that this may be the very condition to achieve a state of macroscopic quantum coherence. The idea being that we never leave the system, let the system achieve thermodynamic equilibrium by constantly delaying the onset of relaxation to the equilibrium. Hence, the production of maximum entropy is delayed. The system may violently react by generating anomalous emergent phenomena, such as, but not limited to, inertial mass reduction, which we're going to talk about here in a minute, I think.
And this speaks to what I call the Prigogine effect. This is the work of Ilya Prigogine. You can say in a way that the Pais effect is the engineering of the Prigogine effect, what I call the Prigogine effect. His Nobel Prize, I believe, 1973, if I'm not wrong. I remember that his Nobel Prize lecture paper being written, I think, December 73. But anyway, he also wrote a book called Order from Chaos, or Out of Chaos, very interesting. He was, I believe, chemistry, but Ilya Prigogine was an incredible mind, and he basically his idea was the ordering of what he called dissipated structures. That chaos can be ordered under certain conditions. The idea being you're dealing with a nonlinear medium, for example, a plasma, You drive it far from equilibrium, hence accelerated vibration or an accelerated spin.
Yeah.
And then you have a constant electromagnetic energy going through it, like a flux of some kind. And you're able to get these dissipative structures. I think he used the example of Bernard's, something called Bernard cells. Bernard, I'm not, it's French. I should know better since I took so many of them. I believe it's Bernard. The whole idea is, for example, on a thin plate, if you have a layer of oil, very thin, and you hit the plate from underneath, a metal plate, so you need conductivity there to make sure, if it's a dielectric, this thing will never get hit. So the whole idea is that they form these in time. They form hexagonal cells. Hence, something that begins chaotic, the movement becomes ordered.
Yeah.
And he used that in his December 19th. An incredible. I suggest everybody go and try to find the Nobel Prize lecture by Ilya Prigozhin. I believe it was 1973. Something about time fluctuations, structure. Anyway, very interesting paper.
Yeah,
very
you mentioned.
paper.
I think this may be similar, and let me know if it is or not. But I think you mentioned driving the plasma from equilibrium that will begin to self-organize, and that the electrons will begin to move in lockstep in one giant matter wave as well. Any
Yes,
comments on
yes.
that?
I actually used the phrase that another great used, Wolfgang Ketterle. I absolutely love Professor Ketterle. The only one to reply kindly to my emails. Like he, even though he would not support my paper in archive, he gave some very good reasons for it. And I mean, I'm 100% sure that if I would have kept nudging him and stuff, eventually, he's that kind of person. I truly see people like that. People like that should get Nobel Prizes, not people that deride others and make fun of them, call them cranks and crackpots. Please, come on,
I've had
man.
similar experiences with academia, and the ones I
Very,
respect, I'm with you, are the ones that the people that are willing to talk to anyone, right? Not regardless of what their pedigree is.
that's
right?
Professor Ketterle.
People that
One of the
humble
greatest.
themselves, people that don't consider themselves to be soothsayers. So those are the types of
He
people I
got his
like to
Nobel
talk to.
Prize for BEC, by the way. Yeah,
Oh, there we
he
go.
showed it. I think by combination of something called evaporative cooling and laser cooling, you can actually cool atoms with lasers. Isn't that cool?
That's really
But
cool,
anyway,
actually.
there's a
Relevant.
lot of stuff you can do with lasers,
So
especially with plasmas. But anyway, I
here's
digress.
I'm gonna press you on this next one then. So is
Yeah,
it feasible to work with electrically charged solids then? I know we've talked a lot about plasmas, but what about solids in general? Any theories there, hypothetically speaking?
it's possible under certain conditions, but you need electric charges on the order of coulombs. And it's not easy. You can use pelletrons and something. The pelletrons are a modern version of something called a Van de Graaff generator. So you can actually get high charges on a particular metallic substrate. But it's not simple, and it's not easy to keep that charge from discharging to the medium. Sometimes you need high pressures. It's how should I say? It's complicated. So I prefer simple things, and I think the best way to do this is with plasmas. Now, I'm not saying that plasmas are easy to subdue. As a matter of fact, they're a very interesting animal. I sometimes think plasmas have consciousness of their own, but I digress. Um yeah,
Okay.
they have like almost like a double layer. You have to study what the Hans Alfvén thought of plasma. It's very interesting. For example, there's another great Anthony Peratt. The whole idea is that our universe is more than 99.99% plasma.
Yeah.
So okay, and hence the Bussard ramjet. The whole, but then anyway, I'm digressing on so many levels. Okay, go ahead, sir.
I'm sure that the people who are being quoted and referenced will appreciate all of the shout outs that you're giving them. So that's why I don't want to slow you down at all. So, I mean, the next thing kind of feeds into what we were talking about with your slides, which is, and as much as you can speak to it, how does inertial mass reduction work, and what does it mean for the capabilities of both technology and propulsion in general?
It works the way that I expressed it in my public domain
Got it.
papers.
Yeah.
What I can speak to, even on an experimental level, is, for example, the one thing, in my opinion, is most important is to create these holes in space. That's why when you show, I I wanted to make sure that the person that I have the interview with was actually you. Look, this is my confessional. So I actually went to a podcast called The Confessionals. I think Merkel Media or something. Really good, tremendous, really good dude too. That dude.
Yeah, he's a good
But
guy.
anyway, a very very nice guy. By the way, you come across, oh man, you come across really good in that podcast. Bravo.
People
Now,
should check it out, by the way. Anyway, go ahead.
When I saw what those orbs did, the local points, the locus of points that they formed, and the moment I actually slowed down and started, because I actually saw one of them, actually a couple of went in front of the nose of the aircraft, and this thing was, we talk almost free fall. So we talk about very high speeds, and I kept on thinking they're trying to form a locus, like almost like a spherical bubble around the aircraft. And then I thought more and more. I said, "Oh my God, they're actually what these three orbs are doing. They're depositing energy at a particular." Even though it goes with a spacecraft, still, I think they're moving fast enough to have a locus of points that you can say it's like a spherical bubble that deposits more and more energy within that particular um, section of space-time to create this breaking of the Schwingelen. And if you do that, you create a hole in space-time. And when I saw what I saw, I didn't anticipate. When I saw that thing, the hole it formed, and then I almost saw like a ring that formed around the hole. It was like a refraction of the superfluid nature of. I said, "Oh my God, this is the Pais effect." And then I had to cool myself down. Say they would never believe that. Most likely, Ashton will have to go through absolute hell to prove that this is not, oh my goodness.
Well,
And
we're going through it, sir. We're going through it.
Yeah.
No slowing down.
I wish you the absolute best luck in this, because this is the best experimental proof that the quote unquote Pais effect is real.
So we'll have to have a follow-up then for sure, where we take a look at the videos together and go through it. I think the audience would absolutely love that. For today, though, I just want to stay focused on the science, just because, I think we want to vindicate you and your science here. And I think we've done a great job so far of explaining how it can be practical and real, right? As opposed to the detractors who want to dismiss it. Now, if you have this inertial mass reduction craft, do you know what would that look like to the observer as they're watching that move? And would they produce a field, or how does that work? Yeah.
Have you ever seen Star Wars?
Oh yeah, I can see your shirt, by the way. But
the X-wing. Oh, I pride myself all the way. Part of the resistance, baby. Anyway, the Rebel Alliance. But I've always been truly a rebel at heart. But
is it going to look like the hyperspace jump
that
they make?
Did I just say that on a live stream? Sorry. Anyway, no. I meant. Anyway, nothing wrong with being a slave. No, I'm kidding. That's but anyway, well, as long as our existence depends on others, we are all slaves, whether we say 100%. So or not. Is a whole different thing. But anyway, let's call ourselves rebels.
Got it.
While we still
I'm
can.
with you.
So,
we're the Rebel Alliance right now.
Yes, sir. Absolutely. Okay. Now, do you remember how the I think they were called? What were they called? The Imperial cruisers,
the Star Cruisers.
The humongous, yeah. Do you remember how all of a sudden they would just vanish as if a hole was formed into? That's exactly what happens with that triangular structure that I represent in the past.
Yeah.
That's how I envision it, and that's why when I saw what I saw in that video, I said, "Oh my God!" But it's very interesting. And you're 100% right. They have to be autonomous, and I'm 100% sure these were some sort of collision avoidance software. All I remember is that, like, inside the orb, because you also showed the thermographs, there was some sort of a propulsion plant, some sort of a power plant.
You could see the heat signature, right?
yeah, there was something going on in the middle of that orb. But anyway, yeah, I digress. Sorry about that.
No,
Yeah, but that's what
you're
would
doing
happen.
great.
Yeah,
People are loving it. I
yeah.
can already tell. So, okay, so it would look potentially like the hyperspace jump. I think that's really cool.
Yes,
You
yes,
actually just
that's
answered one of my other
exactly what
questions,
it
which was
means.
coming up, which was, do you think that these crafts could be, there would have to be somebody inside them, or could they be remote controlled? I think that's an interesting question, right? With respect to
I believe,
yeah, go ahead.
my opinion, both.
Both would
I
be
think
possible.
you can make this. I think you can make it into an interstellar travel.
That's cool.
I think you can do both, but I think it's far easier to do the. First of all, the loss of human life. Nobody
Yeah.
wants to deal with that. Goodness gracious. So much. Sometimes so much better to have these autonomous artificial intelligent agents. Again, this means if it's true what we saw, that means that AI is not a new thing at all. But anyway,
10 years ago almost,
I
right?
digress. I digress way too much. Oh, I have another theory on something I call the triarchy of sentience. Eventually, we'll talk about it. It's very
Oh, I'm
interesting. It has to
curious.
do with artificial intelligence. For example, in my opinion, you can test whether something has become artificial general intelligence by basically seeing if it can generate given, say, textbook data. So we're not talking about stuff that just pulled from the internet, but stuff that's pulled from physics manuals, something that's been experimentally proven. So using textbook data, given a certain computational power level, I believe as long as the AI agent can generate an original concept, it
Wow.
becomes AGI. And
That's really
AGI,
interesting thinking of
next
Chat
step,
GPT. Yeah, go ahead.
super intelligence is not very far off. So anyway, I'm digressing on so many levels. But
Hmm.
another thing, for example, the superforce speaks to a super density. And eventually I'll talk on that too. Something called, so superforce, super bang, because of the super density, and super intelligence. Again, I call it the triarchy of creation. After all, I'm a crackpot, right? So since my
No,
hubris
sir.
level has been, inflated to the max, well, why not break the swing a little bit? I'm
Hey,
kidding.
why not
All
just
right.
change the whole world? Because that's what I think we're doing here, sir. That's what I think we're looking at.
If you can
Yeah.
prove, that video is for Ashton, that is a Nobel Prize, brother. If I was the Stockholm community, I'd freaking immediately give you a Nobel Prize in imagery or something, or I don't know, like creative thinking, or
I'll just take a
I just got
Pulitzer,
something.
I don't need the
Just
Nobel
got
Prize.
something.
But yeah, that's only if,
You
like you,
definitely get a prize. So
I
yeah.
also have to say at this point that I would never hurt myself. And yeah, I'm never going to do anything like that either. Just want to make sure that
Oh
that's
my
on the
goodness.
record here.
Yeah.
Just kidding.
Yes. Yes. Neither Ashton nor I would ever suicide ourselves.
No,
Thank you.
never in any circumstances.
That's right.
So also, I just want to dig into a little bit kind of what you just mentioned, which kind of digs into the stuff we were talking about. Is in your patents, you talk about nonlinear medium using a plasma resonating inside a cavity
Yes.
related to microwaves. And then you also say that you can convert high frequency electromagnetic waves into gravitational waves. Can you speak to that at all?
That has to do with another paper I put out on, I think, the Society of Automotive Engineers. Remind me to send you that paper.
Okay.
I also have that. I think, yeah, it's like starts with 2040, that paper. But anyway, it was published in the, it's a paper that was needed to get the patent. That was incredible, though. That office action was a first. I mean, they actually approved it as a first, the high frequency gravitational wave generator. It could be because prior to this, they were shown to be. I mean, we're talking about the genius of Kip Thorne here,
Yeah.
and Barry Barish and LIGO, for goodness sake. I mean, the greats, experimental and theoretical Kip Thorne, of course, just like Penrose got it for black holes. But anyway, and by the way, Sir Roger Penrose, or you should be called Lord, in my opinion. So Lord Penrose, if you're ever watching this, there are no such thing as space-time singularities. I'm sorry I disagree with you. We can have an argument on it. I think Abba Ashtekar is correct, as in there's a quantum bounce. So in other words, it never goes to zero. It goes to something on the order of the Planck density, which talks to the super density. But anyway, that's a whole different ballgame. We'll talk about the super density one day because it talks to the super bang, not the big bang, the super bang. All right. All right, sir. Go ahead.
Yeah, so I've got a few more questions that are kind of similar to stuff we've talked about. I don't know if some of it's going back. You know, and I think I heard something on your Theory of Everything podcast where you talked about there being a thin insulator regarding your inertial mass reduction craft. Does this actually have to be a physical element, or can this be something that can be produced by a field of some sort as well? What are your thoughts on that?
It's a very good question, sir. I'll leave it there.
I love it. I love when I get that answer, honestly, because the same reason why I send in Freedom of Information Act requests. Like, I don't care what the answer is, because no matter what the answer is, I glean information off of it as an investigator. Now, I guess the next part too is kind of related to what we were just talking about with, not to go into the videos that we were talking about, but the effect, what we see there in the videos is, you mentioned, I think, with the pairing up of electrons causing potentially a suction effect, or potentially creating a void that may create the suction effect.
It creates
what
a void within the vacuum. So it's exactly what you see. It's almost like a black hole.
Yeah. But is it a black hole? I guess that's my question.
See, oh my goodness,
Does it matter like how you define black hole?
I have a feeling between you and I have a feeling that for every black hole, there's a white hole.
So I thought that too.
So in other words, it's kind of like a wormhole, kind of. So you have the ability to actually transport from one point to another. For example, going from point A to point C without actually going through point B.
Yeah.
I think
I've always wondered
we
that too.
don't really understand what the quantum vacuum is all about. And I have a feeling there's so much more to physics that I think we're still in our infancy. We think we almost know it all.
Oh, no,
I think physics is almost, I would say, 3, maybe 4 months old. That's a long time till this thing becomes an adult.
Basically, I think JFK mentions that too, is that the greater our knowledge increases, the greater our ignorance unfolds. And I look back at that and I think that we think we're so advanced, but we are still potentially cavemen compared to where we could possibly be, is my view. And it's funny you bring up the black hole, white hole situation. That's always something I've wondered about too, because what we see in physics is symmetry a lot, right?
The idea that if you must have an entrance, why not an exit?
Interesting.
Yeah.
And so when you're generating this void in the space-time continuum, which I believe you argue with these certain energy densities, getting to that, would this potentially energize particles outside of the void, do you think? Or any thoughts or theories on what might happen there? And do you think it would at least look like a black hole?
I mean, I could speculate. I can give you my speculation.
Yeah, please.
I think it would be a whole local phenomena. I have a feeling almost nothing. Maybe something that I'm not sure whether, for example, the clouds, because you mentioned there were clouds, like were those clouds in any way, could you see them move in any way?
Only
and
slightly.
I'm not sure. I have a feeling that the effect would be highly local.
Interesting.
And it's as if a portal is open within a fabric of some sorts, but somehow this fabric has the ability to recongeal almost spontaneously.
It's weird.
Again, the whole idea is that once you remove this energy density, this thing just comes back. And that's why super intelligence. I truly believe what we're dealing with, the energy, the universe is a sentience. It's a sentient being. And I tell you, we better be careful what we do with our planet, because you know what antibodies are.
Yeah, they fight back, right, against anything that doesn't unwanted things, right?
Yeah.
Well, that makes me think about some other theories that I wouldn't mind talking with you on another podcast as well, which is into more of the, what are the implications of, this advanced technology, where it came from, and what it would mean for, lots of other philosophical approaches. But we can save that for another time.
That's another thing. Physics and philosophy must be bridged. Again, we must marry these two.
Agreed.
The divorce that went between physics and philosophy should have never been allowed. I believe physics has so much to gain from remarrying philosophy. And I think Carlo Rovelli, others like him, Lee Smolin, oh man, that's a physicist. I would love him in the committee, both of them. But I think Lee Smolin has taken a Canadian citizenship, and there's a. So in other words, the people that would be in this committee would have to be United States citizens due to certain things. I would say, and I'm pretty sure the committee would be. Unfortunately, I would love to have it televised, but I have a feeling, my betters, my superiors would not, would agree maybe to a skiff conference rather. Anyway, I'm not gonna go there.
Well, that's why I'm glad I don't have
unfortunately,
any NDAs and don't have to worry about those types of things. But I understand the
yeah.
prickly situation that you might be in, sir. So again, I just appreciate that you're, able to talk freely about this type of stuff. And yeah,
Well,
you can
thank you,
always
sir.
reach out
Thank
if
you for
anything were
this.
to happen.
It's just that I was super furious when I saw the changes they did to the Wikipedia page. I mean, for goodness sake, pseudoscience. That's like vomiting in my face and then spitting on it too. I mean,
agree.
what else? You gotta take a shit. I'm not, excuse my language.
Oh, you're fine.
I grew
I'll
up in
mark
New
this
York
as not for
City.
children.
A tapestry of obscenity second to none.
Yeah.
But anyway, yeah.
So I have only a couple other questions. I was thinking maybe we'd open it up to some live chat questions if I see
Sure.
some out there. So one last thing that I've been curious about, which is, and this kind of goes into the UAP phenomenon, but it's definitely related to your scientific approach, is do you think this craft or your craft that you have kind of patented can go through solid matter, or are there limitations to it? What is your thoughts on that? Because I know that they talk about like different being able to go through different mediums, right? Water, air, space. But what about solid
Transmutation.
mass, right?
Let me just say there are no impossibilities, just conditional possibilities. Under certain conditions, everything and anything is possible. The trick, and this is where it all comes, is how to engineer those conditions.
Interesting.
So in a way, I've answered your question. In a way, I haven't. But I'll leave it at that.
Okay.
I think one of my favorite characters in shows. It wasn't the American version of House of Cards. It was the British version. His name was Francis Urquhart. FU. It's pretty interesting how the initials goes. And he used to say, "You may possibly say so. I could not possibly comment." I don't know, but that thing stuck in my mind.
That show was
All
great.
right,
At least I watched the American version until the last seasons. Unfortunately,
don't mention the name or you'll get
I'm
you'll
not.
get this.
I don't want to get us removed here.
It's a total loss though, because oh my God,
it was great until then.
Remember The Usual Suspects?
Oh,
I mean, whoa. Anyway,
great movie.
Yeah.
So one thing I want to ask or say as well is just kind of a general statement I have before we jump into questions is that, if your daughter's watching, I want her to know that you are a great man. And anyone who says negative stuff about you, they can come talk to me because that's nonsense. Just for you, your dad is an amazing person. He's going to be a historic figure, potentially even in the history books. So ignore all the nonsense that the haters would say. They don't mean anything. They don't even matter, honestly. And that's the way you deal with them, is you don't let it get to you. So that's all I wanted to say to her if she's watching.
God bless you, sir. God bless you for that. Thank you very much for saying this. She tries. She tries so hard. One time I found her crying and she was reading. I said, please, oh my God, Reddit of all things. I mean, you don't read that stuff, But anyway, she's gonna be 12 soon enough. But still, she's a sensitive kid. I wish she took it more from her mother. But she took it from me, unfortunately. So she's a great kid. Thank you for that. God bless you, sir. If you have any children, same goes to yours.
I appreciate it. I don't, but I appreciate that anyway. I'm sure my family will be happy to know that.
You were able to prove this. definitely get a prize.
Yeah. To me, it's
And
just about the
again,
truth, you know.
let us reiterate: neither Ashton Forbes nor Salvatore Pais would ever suicide ourselves. Thank you.
100%. And yeah, for me, it's about the same name as my podcast, Hard Truths, right? These are hard truths that are hard for people to accept, but they are true. And we still have to look, even though we don't want to accept it. We have to look.
Yes,
So
sir.
I've got a couple questions from the audience here, if you're ready to
Go
go.
ahead.
I don't.
Absolutely.
One of the first ones here is they want to ask you about the relationship between Pais effect and exotic vacuum objects. Apparently, they go by a number of different variety of names. Are you familiar with
EDOs.
those? And
Sure,
can you speak to
sure.
that?
EDOs. Yes, yes. That's a very interesting. The whole idea of supercavitation, the whole idea of sonoluminescence, and what was the name of that gentleman? I remember reading some papers on him. He was quite an engineer. Shame on me for not remembering the EDOs. If they can put that in the live stream, that'd be great. So you can. But anyway, um, I'm not quite sure if there's similarities. I think mine is a more general form of it. Mine is really the engineering of the Prigozhin effect. That's
Yeah.
what it is. I think that's the best way to say it. It really deals with taking things far from equilibrium, and again, the whole idea of rapid acceleration transient, the whole idea that you don't have the time differential of your acceleration is non-zero. That's very important. And don't forget equation 7. Please do not forget equation 7 in the IEEE TPS paper, that the plasma compression fusion device. It speaks to something very interesting, an energy runway that an exponential increase with time and accelerating vibrational frequency. Read that. Be very careful when you look at that equation. That says a lot of things. So I hope I answered some
Looking
of
at
that.
it.
Yeah,
I see
I
it.
hope but definitely, God, what was his name? Now it really drives me crazy. He was quite a character, an incredible mind. He also went through hell. Uh,
I'll put it on the
God,
screen here for people to see for a second.
shame on me. Shame on me for forgetting that man's name. Really, God.
So there's the answer for that. Oh,
So,
no problem. So somebody else had another question, which they wanted to ask about your thoughts on ER equals EPR. What are your thoughts on that?
Einstein-Rosen, the Einstein-Rosen bridge equals Einstein-Podolsky-Rosen. The whole idea that quantum entanglement really speaks to this bridge between these two particles. But think what particles are. The superforce says that the proton can act as a black hole. So if so, why not the electron? Maybe the electron is also a black hole. Maybe all particles act as black holes. And as a matter of fact, maybe that's why we see these quote unquote particles not disintegrating. For example, the
Yeah.
proton, the decay time is on the order of 10 to the 34th. I don't know exactly the unit of measure, but even seconds would be horrendously large. But most likely the proton will not decay unless you do something. Again, I am not sure exactly how the superforce speaks to, for example, the Higgs field. I think, for example, the Higgs field speaks of a different scale. I think the superforce is so fundamental; it exists at the Planck scale. It actually drives everything. Put it this way: it is the force to rule them all.
Yeah.
One force to rule them all, one force to find them, one force to bring them all, and in the darkness, find them. And it's interesting, they talk about dark energy. Maybe that's what the darkness refers to, but anyway.
Okay,
Yeah.
that's interesting. Yeah, some other stuff. Let's see what people have. Well, people wanted to first say that we love you back. So everybody's a big fan of you in the chat right now. Just let you
they're,
know.
they're great people. Thank you
People want to
very
know
much.
what gives you hope for a better world. I think that's an interesting philosophical question.
Okay.
What gives you hope for a better world?
I I had to turn the TV off in the morning. I was hoping for some better news. And again, physics and politics should not mix. So I am totally apolitical. Consider me totally. I'm okay, but I will say this, and Listen carefully, and I'll say this in both Romanian and Russian. Slushайте. Ascultă bine. And now I will say what I have to say. Credo in unum Deum, Patrem omnipotentem, nihil sine Deo. Baruch atah Adonai Eloheinu melech haolam. Bismillah, Yirachman, Yirahim. Inshallah, Mohammed, Iraizuli. Different languages, different religions, yet signifying all is one, one is all. Unless we come together, we shall fall apart. Unification.
Yeah.
That's what all these languages speak to the one truth. And you know what that truth is. Why can't we just come together? This is the only way we have a chance. A unification of civilization will give us the ability to go to the stars. Otherwise, that chance will never come.
Yeah.
Not the way, not the path we're on. That's all I have to say.
Awesome. I think they also figured out who the doctor was. Dr. Ken Shoulders, I think, is the potential name you were thinking of.
Oh my goodness.
Chad had it, was on top of it for you.
What a great dude.
They got it.
Oh my God. Remarkable. Yes. Remarkable mind. As a matter of fact, this whole idea of the negative energy, then, the whole idea of the formation of the hole through which this thing is sucked.
Yeah.
That's the science of someone called, I forget. He used to go by the name David Froning, but I believe his name was Herman David Froning. I think David was his middle name, but David Froning, Dr. Froning, University of Adelaide, I believe, Australia. Very interesting man. You have to look. I think in one of my papers, I actually cite him, and I regarded him along with people like John Brandenburg, Paul Murad. He recently passed from cancer. These were great people. These are great people. Some of them are still alive, but I believe Dr. Froning and Mr. Murad are no longer with us. Mr. Brandenburg, thank goodness, is still with us. He is a good man. He should be listened to tremendously. His GEM theory, GEM, gravito-electrogravitic, electromagnetic theory, GEM, GEM, should be looked into. Absolutely. It's fascinating. And he also talks to the pointing vector. I mean, he was able to actually show the mass of the Higgs particle.
That's huge.
Because we're really talking to the Higgs field. There's not.
Yeah.
That's why the whole idea of the God particle, please. There are no such thing as particles. There's fluctuations in fields. What exists is but anyway, again, digressing. Sorry. Next question.
You're fine. No, I think we're drying up, but I have a question for you as well, which is another physicist that I've been talking to has a theory called dilation theory. And I think that the way he would describe is that time is a fluid symmetry, and that you can essentially take gravity out of the equation. And it's another way to simplify the mathematics. I think similar to what you do, achieves the same, perhaps, conclusion, but goes about doing it a slightly different way. And the reason why I liked his theories in general, I'm just curious of your thoughts on them, is that, the idea is the less mass, the faster time flows. The more mass, the slower time flows.
Is incredible.
It's pretty cool, right? Time dilation.
Time. I wish I understood. I think of time as some sort of energy field. I wish I understood more. For example, gravity responds to time. Why? And again, we're talking about physical time here. We're not talking about the time as we understand measured by clocks, because remember, clocks themselves are made out of what? Atoms, and atoms respond to the quantum vacuum and the manipulation thereof. So you have to be very careful by saying, oh, there's no such thing as physical time. Today is equal to tomorrow. Please, I don't think we really understand time, what it really means. Yeah. And since we don't understand time, how can you say you understand space-time? The unification of the
same, right? Yeah.
So we have to be careful to that's why I'm saying we are only in the infancy of physics, maybe 2-3 year month old compared to what other. Anyway, yes, definitely not an octogenarian. No, all right.
Yeah.
Yeah.
So I want to go ahead and thank you here. I'll let you go ahead and say you have last words. I want to let you kind of say whatever you want to say. It can be, anything that's come to your
I
mind
just
here.
want to say one thing and one thing. I hope we have other interviews.
We will.
I truly, I respect you, sir. I respect you 100%, and I honor your investigative approach, your research, and your ability not to give up. That's what it's all about. No matter how much crap, how much fecal matter they throw at you, just every now and then deflect. Yeah, it smells. What can you do? Keep on going, achieve
Sir.
that objective. And trust me, Ashton, if you're able to prove this, wow.
Yeah.
And again, stating this for the audience, neither Ashton Forbes nor Salvatore Pais would ever suicide ourselves.
No,
thank you.
never.
Thank
Actually,
you.
I did have one last question too, which I
Yes,
hope
sir.
is not because you work for SpaceForce now. Is that correct?
Uh,
Or with them?
Since we have people. Sir, to me,
Too much.
I can't stand lies. Lies
Yeah.
to me, like this whole
Me
idea
neither.
that lies, layers of lies upon lies, becoming accepted truths. For God's sake,
Mm-hmm.
it's just a total anathema, like sacrilege to me. So I'm not gonna lie. No, I don't work for the Space Force right now. I
Okay.
work for the United States Navy.
Got it. Okay.
But I'll leave it at that. Yeah.
Okay. Yeah, no problem. Well, in
All
that
right.
case, then I would just close out and say, this is the Hard Truths podcast, #1. This is a big one. I mean, I respect you more than you respect me, as much as you might think that. We each have our own frame of reference, and perhaps it's a balancing act. But you're one of my favorite people on the planet. I've been talking with you offline as well. And I want nothing more than to vindicate you and your science that you've put out there. And I want you to stay strong as well, because I know that you have been getting attacked. And hopefully this podcast went to some degree to have people take you seriously, which they should. Absolutely.
I really need a committee. I need a committee of highly credible, highly accredited scientists, Nobel Prize winners. We talk about Lee Smolin. We talk about Seth Lloyd. We talk about Brian Keating. We're talking about even Eric Weinstein. Yeah. I mean, why not? Even though he's not of the so-called correct physics pedigree, his idea of geometric unity is quite interesting, even though some papers were written against it. Please, everybody should have some say. But again, give me a committee of highly credible people. And in 1 hour, I promise you, 1 hour, I can prove to them that I at least know what I'm talking about, at least that I'm correct and at least partially correct. And if not, sir, I promise never to do a podcast again, never to even publish one more paper. That'd be it.
Well, make sure that you're successful.
Which between you and I, it's not happening anyway. So it's like I'm getting so many rejections. I just stopped. Now I just go for preprints, because in my opinion, it's almost as good as as long as the server survives and you're able to. That's why I asked you, please show that paper to everyone Just send it out, because it's like a domino effect. Even if the service gets shut down, somebody will have that paper, and somebody will say, "Damn, this crackpot wasn't such a crackpot after all." But anyway.
So do you want to plug anything as well? That was a good. Somebody brought that up. Anything you want to plug? Do you have a Twitter? Do you have any place where people can find your work?
No, sir. I'm totally off social media. Oh my goodness, are you kidding me? And that again, that thing of I think between you and I, the having social media is conducive to that S thing that we call
it definitely is.
Anyway, so no, absolutely not. So I just want to say, please also go on Kurt Jaimangel's Theories of Everything.
That was a great podcast.
Please also go to Tim Ventura interviews. Also Project Unity, Jay Anderson, incredible dude. And don't forget Jeremy Riss, alien scientist. Very interesting. And that group of people, those two dudes, Jeremiah the engineer and Michael Perrone, he did a thing with Tim Ventura on LK99. Watch, whoa, he's a real material scientist.
Yeah, I was watching
So
that,
anyway, yeah,
looking at it closely. So yeah,
yeah,
Sal's going to be on the Alien podcast or the Alien the Scientist stream next week. So guys, check that out for sure. I'm sure it'll be a great follow up to what we've been doing here as well. I just want to thank you one more last time, Sal. I couldn't be more appreciative. And we can chat for a few minutes offline here. But thank you very much,
absolutely.
chat, and everybody who's on here today. Everyone who's there on the podcast. This was the very first inaugural of the Hard Truths podcast. Have a great day, everybody. Okay. Closing down the recording.